It would be thought that aluminium, as one of the most abundant elements in the Earth's crust, would seem to be the most common metal. However, it could not be produced efficiently until 1886, as its high affinity for oxygen prevents it from being able to be reduced to the metallic state using carbon or carbon monoxide. A process developed by Charles Hall electrolyzed a molten solution of alumina, which is Al2O3, with the mineral cryolite, which is Na3Al at 950 degrees centigrade. Alumina is first produced by calcining aluminium hydroxide, which has been precipitated from an aluminium bauxite solution using caustic soda. Aluminium obtains a microscopic layer of oxide in air, but this then prevents any further oxygen contamination. This protective layer can be increased in thickness by anodizing. The aluminium atom is made an anode of an electrolytic cell, liberating oxygen, and for decor it can be dipped into dye to colour it. Aluminium alloys are not all heat treatable though. Copper and tin have always been alloyed as brass for thousands of years since ancient beginnings of civilization. However, it is currently very expensive and is being replaced by aluminium and plastics. Copper is produced similarly to iron with only the addition of flux to the blast furnace. This only produces highly oxidized copper though, and it is then refined electrolytically in sulfuric acid solution or by molten contact with green wood poles that produce reduction gases. For high conductivity, it is further deoxidized with lithium. Tensile properties are improved with addition of arsenic. Tin is produced mainly by continuous electrodeposition, as a thin steel strip is quickly passed through an electrolyte and so has the tin electrode deposited onto it. This is then flash melted to give it a bright surface finish. Tin lead antimony gives a strong alloy called white metal, which is used in bearings. Cuboids of SBSN crystals make a very hard dispersion in the alloy, especially with added copper at 3%. Pewter, useful for decor items, is composed of 6% antimony and 2% copper alloyed with tin. Well, titanium is stronger than steel, and it is reduced as a chloride with magnesium in a closed reaction vessel. Then it is arc melted as a pure sponge electrode into a water-cooled copper vessel in vacuum or within an inert gas atmosphere to become ingots. Alloys are added before arc melting, the main alloy for aircraft and structural forgings being aluminium. Tensile strength can reach 1500 meganewton meter squared used in aircraft turbines. Well, thanks for watching our video. You'll know that aluminium can be used in these window frames and other extrusions for construction, but what it can be used also, of course, is for tin cans, or should I say aluminium cans, for beer cans, VB cans, and this information has been extracted from VB John's Introduction to Engineering Materials.